Hey guys, in this video we're going to be covering KC3. So everything that we're going to be doing in this video is everything from Unit 3. So dealing with imaginary numbers, very similar to KC2. And again, if you want to practice these questions, look at those hints, go use your note packets, activity packets, feel free to do so. Alright, so number 23, we are adding two binomials together. So we have to combine like terms. So negative 23 and a negative 2, they are both negative, and that combines to give me a negative 25. My other like terms here would be a positive 6i and a positive 8i. So they're both positive. We add those together to give me a positive 14i. When we are subtracting, one thing we have to be careful with is that subtraction sign is going to flip the signs of the second binomial. So the first binomial doesn't change. 5 plus 7i stays exactly the same. But that negative sign is going to change the second binomial. So a negative 1 times a positive 20 is going to be a negative 20. And a negative 1 times a positive 9i is going to be a negative 9i. Now it just kind of becomes like an addition problem, and we can combine our like terms. So the ones that don't have i's, 5 and a negative 20, they have opposite signs, so I find the difference, which is 15. Keep the sign of the bigger number, which was negative. Next is my I terms, positive 7i and negative 9i. When I combine those two together, they have opposite signs, so I find the difference, which is 2, and then I keep the sign of the bigger number, so it should be a negative 2i. Don't forget those variables. When I am multiplying, we have to use a Punnett square box, or for those of you that like to FOIL, you can feel free to FOIL this Punnett square box. So I'm going to go ahead and write my binomials out. I'm going to have that 10 and that positive 3i, right, keeping that whole binomial on one side. And on the other side, I'm going to write the other binomial. Make sure you write the signs. It was a negative 8 and a positive 4i. All right, now I'm going to go ahead and multiply everything in. So negative 8 times a positive 10 is a negative 80. Negative 8 times a positive 3i, I multiply the coefficients, so negative 8 times a positive 3 is a negative 24. Can't forget that it has an I. 10 times a positive 4i is going to be a positive 40i. And then a positive 4i times a positive 3i, well, 4 times 3 is 12. And I times I is I squared. Please remember that it has a squared here because each of these have an I. Don't forget that. All right, now I'm going to write all those terms out and see if there's anything I can combine or simplify. So negative 80 minus 24i plus 40i plus 12i squared. All right, I'm going to combine my like terms. Some like terms I see here are a negative 24 and a positive 45. So bringing down my negative 80. Oops. So I'm going to bring down my negative 80. When I combine negative 24 and a positive 40i, that's going to give me a positive 16i. Still have my plus 12i squared. Now the other thing to remember is that anytime you have an I squared, right, I squared here is going to equal negative 1. So you have to replace that with a negative 1. So what this is going to end up looking like is negative 80. Keep my colors the same here so we don't get lost. Plus 16i plus 12, but now I'm going to replace that I squared with a negative 1. So this is going to change to times a negative 1. My equation then is going to be negative 80, still plus that 16i, but now I'm going to have a positive 12 times a negative 1, that's going to give me a negative 12. My like terms now are going to be negative 80 and negative 12. Write my answer over here. And that's going to give me negative 80 minus 12 is going to be a negative 92. Can't forget my 16i. So plus 16. So one of the biggest things on these ones when you multiply is don't forget to switch that I squared to a -1. All right, that's going to change the sign of that last term. Then it's going to combine with whatever else did not have an I, so whatever the other constant was. All right, target 3B, we want to solve for x. So again, we are trying to isolate the x value. So this is whatever's being squared, so I have to get rid of that 19. So the opposite of adding 19 is subtracting 19 over to the other side. That's going to give me x squared is going to equal a -19. I still want that x by itself, so I'm going to go ahead and take the square root of both sides. When I take the square root of x squared, I'm left with x. I know I'm going to have a positive and negative answer here, but I need to take the square root of that -19. So I'm going to remove that negative sign. Remember, we're multiplying by a -1, so I'm taking that out. And since we cannot take the square root of a negative, the square root of this negative becomes my I. Alright, now I have the square root of 19 still underneath my radical. It does not have a square root, so that would be my final answer. Keep in mind here that this does have two solutions, right? X could equal a positive I square root of 19, and x also equals a negative I times the square root of 19. So that plus minus sign, right, this symbol right here is where I get that positive sign and that negative sign in front of each term. So we should have two answers for all of these expressions or equations. All right, for number 27, we want to solve for x. You see that we have three terms here, so what that's going to tell me is that I have to complete the square. So when I complete the square, I need to get the first two terms by themselves. So I'm going to subtract that constant over, so minus 39 over the other side. I'm going to have x squared plus 4x. I'm going to have some constant. That's what I'm going to try to figure out. I have that negative 39 now on the right side, still plus that same constant. All right, so I'm going to complete my Punnett square box over here. And the number that I have to divide in half is whatever has the x. So if I take that 4, I want to chop it in half. And again, I'm going to put that positive sign just so I don't lose it because it was a positive 4x. So positive 4x divided by 2 is a positive 2x. That number is what I'm going to place on the diagonal of my Punnett square box. All right, that's going to help me out to figure out what the outside is. So this is going to be an x and an x. To get my positive 2x, I would have had to multiply by a positive 2 and a positive 2, which gives me my constant, use green, because 2 times 2 is a positive 4. I am multiplying, so that positive 4 is what I'm going to put on each side. All right, from there I want to factor. So I'm using a different color here. The left side is the perfect square trinomial. So if I would have asked you to factor that, you would have gotten these same sides of that Punnett square box. So the left side is just going to be whatever you had on the side of your Punnett square box. There was 2 of them, so I am going to square it. On the right side, I just need to simplify my negative 39 plus 4. So one of the biggest mistakes is that I've seen some people, they forget to add what was already there. So this whole thing is what I need to combine together. So negative 39 plus 4 is a negative 35. All right, so from there, we still need to solve for x. So I'm going to go ahead and extend this over here. And I'm going to move my board over. So I have that x plus 2 quantity squared. X plus 2 quantity squared still equal to a negative 35. So my goal is to get that x by itself. So I need to take the square root of each side. So taking the square root, I'm going to be left with x plus 2. This is going to be a positive or negative square root. This is going to be a 35 times a negative 1. Remember, we don't like negative signs underneath our square root. So x plus 2 is going to equal a positive or negative. I'm going to remove that I. Square root of this is my I. I'm taking it out. Whatever is left, though, is still positive 35. So once you remove that I, that number does become positive. Still, though, my x is not by itself. So I need to get this 2 over to the other side. And I'm going to do that by subtracting 2 over. Alright, so my final answer here is going to be x is going to equal that negative 2 that I moved over, plus or minus I times the square root of 35. So again, how many answers do we have? We do have 2 because of that plus minus sign. So it does give us 2 answers. Alright, looking at the next question, number 28. Again, it asks us to solve for x. So that's kind of what we were just doing in like this step, like right above it. Same step. We're trying to isolate whatever's being squared. So I'm going to move that constant of that 50 over. I'm going to subtract it to the other side. It's going to give me x minus 8 quantity squared is going to equal negative 50 minus 50 is a negative 100. I want to take the square root of both sides. Alright, so that's going to give me x minus 8 equals, taking the square root of a 100, this is times a negative 1. What is nice is that you can take the square root of a 100, that's 10. So this is going to be x minus 8 equals a positive or negative 10i. So remember that taking the square root of a negative is an I. Check for perfect squares. 10 does have a perfect square. Still got to solve for x though. So x minus 8 equals a positive or a negative 10i. This is for the other problem. I want to isolate the x, so therefore I'm going to add 8 over to the other side. Whatever is the opposite. So x is going to equal positive 8 plus or minus 10i. Again, we do have 2 solutions. We have 8 plus 10i and 8 minus 10i. Alright, target C using our quadratic formula. So the biggest thing I need you to remember is that it needs to be in standard form. So standard form means you have ax squared plus bx plus c equals to 0. Alright, so nice thing is that you will be given the equation and all you have to do is tell me what our a, our b, and our c is. So our a value here is 7. So anywhere I have my a is where I'm going to put that 7. Right? So I see it here and here. Basically just substitute it wherever it needs to go. The b was negative 1. So I substitute a negative 1. Notice the first part of the equation, I do have 2 negatives. Right? Just because it has a negative out there does not mean that you don't have to account for that other negative. Alright, the last letter was C, and our C was 3. So anywhere I see that C, I'm going to substitute in a 3. If it's just asking you to substitute and do not solve, then that's all you have to do. Do not waste your time in trying to solve the question. For number 30, if given this equation, we need to identify A, B, and C. So remember, it has to be in standard form. So I need to put this in order with the x squared term first. So this is going to be 2x squared. Then the one with the x, so that's a positive 16x, and then minus 5 all equal to 0. So stating my a value, notice a is just a number. It's whatever's in front of the x squared. I do not need to write the x squared. Actually, you shouldn't. That's not what a is. A is whatever's in front of it. Our b value is whatever's in front of the x. So that's a positive 16. So again, no x, just a number. And the last term is our c value, and that's whatever doesn't have a letter. So that's a minus 5. Again, doesn't ask us to do anything. All it asks us is to state what each one is. Alright, number 31 asks us to solve and use the quadratic formula. So what we have to do here is get everything over to one side. So what I'm going to do here is I'm going to stack up the terms that are alike. So this 7x, I'm going to move it over, which would mean I am subtracting it with the other x over here on the side. And then my 9, I'm also going to subtract that over because that would be the opposite, and I'm going to put that underneath the 9. Alright, so my terms now are going to be 4x squared because there's no other 4x squared, there's no other x squareds. Negative 2 and a negative 7x. I do have to combine both these terms. So negative 2 minus 7 is a negative 9x. I then have a positive 4 and a negative 7. So positive 4, or not a 7, is a 9. So positive 4 and a negative 9 is going to give me a negative 5. Now this is all equal to 0, and I'm able to state my A, B, and C. So A is 4, B is a negative 9, and C is a negative 5. Notice I don't write any of the x's or x squared because that's not part of the equation. Alright, from here we are going to substitute these terms into our quadratic formula. So always write the opposite, right, because it's the negative. And then we're going to substitute b in. B was negative 9. Plus or minus square root. What was b? B was negative 9 again. We need to square that. Minus 4 times our a value, which was 4, times our c value, which was negative 5. And then the whole thing is all over 2 times whatever a was, which was 4. Alright, from here you're going to simplify. So again, some of it you can do by hand, but some of them you can use in the calculator. Please remember not to put the square root of a number. The square root sign you do not put in your calculator. You can only do the work that is underneath it. So what you're going to do is you're going to start doing this by hand. So x equals a negative times a negative times a negative, is a positive 9. Plus or minus, I am going to draw my little radical here because I'm going to substitute, I'm going to plug in just whatever's underneath it in my calculator, exactly the way it looks with the parentheses. Alright, so go ahead and substitute, go ahead and plug that in. So, when you substitute all the terms, you can simplify some stuff by hand. You're going to plug it in your calculator. Using the parentheses, 9 squared minus 4 times 4 times a negative 5, and that should give you a 161. Notice how I put that underneath the radical, because we still hadn't taken the square root of it. Also, don't forget whatever is underneath in our denominator. Oops, let's highlight that. So 2 times 4 is 8. Don't forget to write that 8, because a lot of people will forget to write that. Those are our 2 answers, right? One thing to remember is to take out any negative, but that 161 is positive, and there is no square root of 161. So we're going to leave our answer like that. Note that it is still 2 answers, right? We have, if you want to split it up, you can. You can say x equals a positive 9 plus square root of 161 over 8. And the other answer would be x equals 9 minus the square root of 161 over 8. Right, so those are our 2 answers. For number 32, we want to determine how many solutions are here. So if you have your graphing calculator, feel free to go ahead and graph these. You just have to figure out how many times they intersect. If you want to solve it by hand, you may also solve it by hand. So go ahead and pause the video if you don't already have your calculator. Otherwise, keep watching. Alright, so I'm going to go ahead and substitute those first equations here. And the first equation was x squared minus 5. And before I click enter, I would just go ahead and push that arrow downward, because then it'll give you F2. And that is just y equals 3. So you have to type in a 3 and click enter. If for some reason you click enter before typing in that second equation, what you can press is Control and then the letter G. So think of G representing graph, and then you can just go ahead and type in whichever equations. I could also tap up and you can see what I already have in F1 and F2. Alright, now I want to figure out how many solutions there are. I do see that it intersects 2 times. To go over how I find those though, I would go ahead and click Menu, go down to Analyze Graph, and I'm looking for their intersection point. So I know that they're intersecting somewhere here, but I have to be just left of it. Click Enter, scroll right, and you will see, I don't know what happened there. You should see the point. My calculator got a little crazy. And I can just see this intersection point right here. So I know one of them is going to be intersecting around negative 2.83, 3, and then the other one should be intersecting over here. So again, need to be on the left side, need to be on the right side, and I get that positive 2.83, 3. So going back to my notes here, if it's determining the number of solutions for the system, you can also graph this by hand. Set them equal, figure out how many times they intersect, solve for those x values. But here, all I have to say is 2 solutions if I use my calculator. And those solutions would be x would equal a positive or a negative 2.83, right? Because I've seen those 2 intersection points of 2.83, a negative 1, 3, and a positive 2.83, 3. So those are my 2 solutions. Looking at number 33, again, you are more than welcome to set these equal, either factor it, use the quadratic formula, figure out those solutions, or you can just go ahead and go back to the graphing calculator. So the first one is going to be x squared plus 6x minus 7. So let me go back to my calculator here. I want to add a new graph. No, I don't want to save it. So the first one was x squared plus 6x minus 7. And then the second one, I don't remember what it was. So it's 2x minus 2. So I'm going to type in 2x minus 2. Click enter. It's kind of hard to see what's going on in my graph. So what I'm going to do is I'm going to click menu. I'm going to go to window. And I'm going to do zoom fit. So zoom fit is letter A. And now I can kind of see exactly where these 2 points are intersecting. So again, I know it's going to have 2 solutions. To figure out what they are, I'm going to go to menu, analyze graph, intersection. I want to be on the left of this point, on the right of this point, and I see I have a solution here at negative 5, negative 12. And the other one is going to be same steps, analyze graph, intersection. Scroll to the left, click enter, scroll to the right, click enter, and I have a solution at 1, 0. So here, my 2 solutions. 2 solutions, and what were they? Well, negative 5, negative 12, and the other one was, I believe, 1, 0. Yep, 1, 0. Again, if you are solving these by hand, feel free to set those equal, factor, use quadratic formula. Otherwise, you can use your calculator. The last question for this section is, what does it mean when a system has no solution? Well, they have a solution whenever they intersect. So if the system does not have a solution, that means that the functions never intersect. Or you can think touch. They never intersect or touch. You can use, it might be 2 parabolas or a parabola and a line. You can say the line and the parabola never touched. So if it has no solution, it simply just means that they're never touching. They're never going to cross. Alright, I'm pretty sure that brings us to the end of this video. And that's everything on KC3. So again, use those hints if you need to refresh anything. Otherwise, good luck.